transformation y equals f of x minus c, we know that this is a horizontal translation of c units to the right. And now we're going to use autograph to look at just the sine and the tangent, I think. So this is y is sine x minus c, with c currently set to 0, so it's just y equals sine x, the standard graph. And we're going to be looking really at what happens to this point. When we change c, which is going to be in steps of pi by 6 here, then all that's going to happen is the graph is going to either shift right or left. There's going to be no change in the amplitude, i.e. the maximum and minimum values, and there's going to be no change in period, so the curve's not going to squash up in any way. It's just going to move right or left. So if we do that, and we move c to pi by 6, then note that the point has moved to here. If we move it again, so it's now pi by 3, it's moved to there. So x minus pi by 3 has moved us pi by 3 to the right, and if we made c negative, so negative pi by 6, it's moved to the left. So note what we have there is x take away negative pi by 6, so of course we'd write that as x plus pi by 6. So this one would be sine of x plus pi by 6, and it's moved pi by 6 to the left. Now we have y is equal to tan of x minus c, with at the moment c set to 0, so that's the standard tan. Note that the asymptote here would be x is pi by 2. There'd be another one here and another one over here, but let's just look at this one. So if we put this up to pi by 6, and then let's just do it again. So now it's x minus pi by 3. So notice that, first of all, the point that was here has now moved to pi by 3, so we've gone to the right pi by 3. Note that the asymptote has also gone to the right by pi by 3. Now it's worth noting that when we apply this horizontal translation to a trigonometric function, we often refer to it as a phase shift. So whenever you see phase shift applied to a wave, it just means that it's been horizontally translated.